Welcome to another video on all about bridges. Time and again we keep hearing about instrumentation of bridges. Before understanding how it is done, first it is more important to understand why instrumentation is done. The aim of instrumentation should be very clear at the onset. What parameters and for what purpose the parameters are being recorded should be amply clear to all concerned. Instrumentation can be done for a variety of purposes, but same should be amply clear before onset of instrumentation. Broadly, these purposes can be grouped in these types. 1. For comparative studies. 2. For theoretical studies and validation. 3. For load rating. 4. For long-term monitoring. Now we will understand these one by one. Number 1. In comparative studies. When there is doubt on any one particular girder or span of a multi-span bridge, then instrumentation will serve as a good tool for comparing the stress strains, accelerations, displacement, etc. of span in question vis-a-vis good adjacent spans, and an informed decision can be taken in the matter. Number 2 reason is for theoretical studies and validation studies. In this category, instrumentation is warranted for following cases. A. Design validation. Wherever any new type of bridge is designed, and there are concern over stresses or deflection in certain members or location, like in a continuous span, or in a fully welded member, etc. In such cases, instrumentation should be resorted to for validation of design assumptions, and design assumption may require updation based on the feedback. B. Effect of running higher. Axle load on bridges. On bridges, instrumentation of bridge is done under existing traffic conditions and test trains, which are then used to validate the numerical models of the bridges. Now, this validated numerical model is used to predict the effect of running higher axle load in form of increase in stresses, strains, deflection, etc. in the various members or point of interest, and then to take an informed decision. C. Effect of high speed on bridges. In this also, instrumentation parameters are used to validate the numerical model, which then is used to find the accelerations, stress or strains, deflections, etc. in particular member or points of interest due to higher speeds, and then to take an informed decision. D. Residual fatigue. Life assessment. Whenever there is doubt regarding residual life of an old bridge, instrumentation is the best tool. We can measure the stress range in various critical members and help in ascertaining the fatigue life of the steel members and determine residual life of other materials based on methods available. Efficacy of repairs. In case of special type of repairs like strengthening of some members by the grouting, jacketing, providing extra steel plates in cross-section, etc. is done. Whether same is giving desired output or not can be ascertained with the help of instrumentation. Now, number 3 purposes is load ratings. Load rating of any member is the ratio of load which the member can carry safely, i.e., member capacity, divided by the load coming on the member in the given scenario. A load rating of 1.5 means there is still 50% reserve left in the strength of the member. The load rating of different members are calculated, and lowest of them is called as load rating of the bridge. This concept is very popular in USA, Europe, etc., but can be used in India also, as it gives idea about how much extra load the bridge can take without need for testing again, if load is to be enhanced again. In this method, instrumentation with present loading test train is used to validate the numerical model and then projected to see what maximum load generates the permissible stresses, strains, or deflection, etc. And load rating of particular members and load rating of overall bridge is worked out. In some cases, the enhanced load is once again run to validate the previous conclusions. Fourth and last purposes is long-term monitoring. Long-term monitoring is costly affair and is required only in special cases and for very important or special type of bridges only. Some of example of long-term monitoring are A. Cable-stayed bridge, accelerations and stress strain in the cable. During long-term monitoring, changes in strains may indicate some problem in foundation or corrosion loss, etc., and repairs can be taken up in time. B. Large pylons, tall columns, tilt, etc. can be measured, and some threshold value may give alarming signal to start taking timely corrective action. C. Deflection or loss of camber in long spans. As soon as loss of camber is found, unusual and progressive loss breaches some determined threshold value, say due to settlement of foundation or due to shortcoming in design, timely warning is received to go for urgent repairs, etc. D. Anemometers can be installed to monitor wind speed, and if threshold value breaches, then train operation needs to be stopped, say, in case of all important bridges. With this, we have covered all 4 types of purpose groups. So this was all about the current topic. Tell us your topic of interest in comments section. Subscribe for more such content.